Thank you very much for joining us. My name is Adam Soroka, CEO of Cavendish, and welcome to Future Downstream. We've had a brilliant opening session and a fantastic Q&A with Shay McArdle. We're now changing our attention from digital, but more so now to the circular economy and decarbonisation, which is a highly interesting topic within this sector. It's moderated by the brilliant Sam Mathew, Director for UK Energy and Utilities for Microsoft. So over to you, Sam.
Thanks so much, Adam. And good morning, everyone. Good to see some familiar faces and names here. For those I haven't met, I'm Sam Mathew. I work as part of the industry team here at Microsoft, focused on energy and utilities. I lead the work we do in the UK with our clients and customers here. I'm very much an industry person myself. I come from the industry. I'm a chemical engineer by background. So this topic here is one that is super close to my heart. So like Adam mentioned, the focus of the panel conversation today is going to be around the circular economy, and especially focusing on some key aspects in there around how we can use CCUS and hydrogen to really get to that scalability that we are looking for. I've got a brilliant panel here with me, and I'd like to bring the panel in at this stage, and I'll hand it over to each of them to introduce themselves and also give some opening thoughts around this industrial sort of symbiosis that we're talking about between scalability, what we want, and how aspects like CCUS and hydrogen can come into play to give some opening comments on this. So with that, I'll probably kick it off, and I will hand it over to Taoufik to kick it off, if that's okay.
Yes, morning everyone. I'm Taoufik Ait-Ettajer. I'm a strategy advisor at Repsol, based here in Spain. And my background is a little bit diverse, mainly in the energy industry, part R&D, part operations, and now in the technology. And most of the time it was related to oil and gas companies. So and at the same time, I'm also external expert of European Commission and also US Department of Energy. So just to give a little thought, and this is really interesting because to talk about downstream and to see the synergy between the downstream and the other parts of mid and upstream for the circular economy. This is really key because it's very important to mention that we cannot, there is no silver bullet for this. And we need to find some synergy between the different technologies and see how those technology can contribute. For example, you mentioned, Sam, the CCUS and hydrogen. And those are topics that are valid for upstream, valid also for downstream. And if we can really find a way to make it economic, I mean, to reduce the cost, the capex, opex, and to get a little bit to get it as a business, that will be a really big win because the challenge is really high. So there are different ways we can do that. Is either extracting the CO2 from the process, or extracting it to store it, or extracting it to reuse it, and all is part of the 3 R's of the circular economy, which is reduce the consumption of material. The second one is reuse, and the third one is recycle. So there is a lot to be done, but the good news here, and I don't want to be too pessimistic, the good news about here is that the oil and gas industry is doing a lot, did a lot, has a lot of knowledge in this area. So we can just reuse or expand the use of some of the technologies to make this circular economy viable from economic point of view. It exists, and probably during the discussion, we'll give a couple of examples. Over to you, Sam.
Thanks so much for that, Taoufik. Absolutely love the reduce, reuse, recycle sort of philosophy that you've set for us at the start, and love the optimistic tone around we've got the skills, we've got the knowledge, probably time for action. Thank you for that, Taoufik. With that, I'll probably go over to Julia.
Surprise, who's it going to be? Hi, I'm Julia Benbow. I work in digital innovation at OMV, particularly on the fuels and feedstock part of our organisation, which traditionally encompassed downstream activities and also support our chemicals team. So OMV's 2030 strategy is about being an integrated, sustainable chemicals, fuels and energy business. And our energy division is focused on the carbon capture and storage aspect, but in fuels and feedstock, as well as reducing our scope 1, 2 and 3 emissions, we're also about making hydrocarbon products from renewable sources and making e-fuels and e-olefins from green hydrogen, and bio-CO2 is one of our 4 routes in fuels and feedstock. And across this transformation, we have a huge focus on the circular economy. And obviously that is dependent on this industrial symbiosis. And we're then through the transformation, building and adapting existing assets, a different product portfolio so that we can take a range of different waste, or you might say alternative feedstocks, renewable feedstocks. And that takes a whole different set of partnerships, a different set of processes to source and process, but also onwards to sell. And we know we need to be flexible enough to process different types of feedstock, but also meet the varying demands, because whilst there's predictions for different sorts of volumes in the future, legislation, the economic environment, different trends impact, and you don't know exactly what's going to be needed when, even though you do your very best to read the crystal ball and the trends and make the most of artificial intelligence and machine learning to predict. It's never 100% accurate. But of course, what we're doing is an extensive investment. We're all in a position where we're putting sustainability and finance kind of on the same bar. And the big challenge is, how do you balance both? There isn't, and it's difficult in an industry that has mastered consistency, trying to reinvent itself and recognize that there is more than one right way to address this complex, wicked challenge, that we're unpicking it and trying to find the right path for us that is effective as well for the rest of our customers and the customers they serve.
Really, really interesting. Thanks for that, Julia. I've picked up a few key thoughts here as you were introducing the topic from your end. I think partnerships and flexibility, and I think this whole concept of having more than one right answer as you go along this journey. Really, really interesting points we'll pick up in the conversation in a bit. But without further ado, Alan, over to yourself for your opening thoughts and introduction, please.
Thank you, Sam. Pleasure to be here. Morning, everyone. So I'm Alan Gelder, SVP for Refining Chems Oil Markets for Wood Mackenzie. Chemical engineer by training. Started working with Repsol in process design and planning many years ago. Been done industry research and consulting for 30 odd years now, with 20 years with Wood Mackenzie in various roles. Have the dubious title of global downstream subject matter expert, which always worries me because it implies I know far more than I do, but always learning. And Wood Mackenzie provides sort of market, it's really around commercial research and analysis on markets and assets, providing sort of outlooks, both very near term, real time, all the way through to sort of long term scenarios to help clients make better commercial decisions. We believe our sort of USP is the interconnectedness of our analysis in terms of our long term outlooks in what we deliver, because we span all parts of the energy value chain and metals and mining, and naturally cover views on sort of hydrogen, CCS, and also liquid renewables. If I was going to offer sort of some initial thoughts, then sort of the house view is CCS has a material role in decarbonising Europe and European refineries, but it's a high cost solution. we see refining being a natural home, early entrant for the adoption of green hydrogen deployment, though the economics remain challenging, but there's lots of policies that are coming into play to support wider adoption. And if we go to the whole liquid renewables front, what we've seen over recent years, but less so in 2024, is that the production of liquid renewables, renewable diesel, HVO, sort of, etc., can provide a significant margin contribution to the downstream industry. The key challenge is actually ensuring you have the right feedstock that is compliant with the legislative regulatory requirements. Sam, back to you.
Thanks for that perspective, Alan. I think really interesting few points there that I'll again like to pick up further on in the conversation, especially around green hydrogen and what you mentioned there about the relation that has with the circularity side of things. But first of all, I mean, wow, what a panel, what experience on the panel, and I'm just amazed by the amount of I guess collective experience and knowledge that we've brought here together. So with that said, I guess there's probably two key sort of lenses through which we're looking at this concept, and that's sort of part of the topic here that we mentioned. So I'd like to get your thoughts, panel, on the CCUS side of things. I know each of you touched upon it slightly, but probably if we just zone in on CCUS as a concept and as a potential solution, as a potential answer. Julia, you mentioned quite like having multiple right answers. So if you zone in on CCUS, just like to get your quick thoughts on where you see that being applicable. What sort of challenges are you seeing, if any, to that being a sort of adoption in the sector? Feel free to jump in.
Well, I think that there's a huge amount of discussion regularly around the storage aspect, and that has the biggest profile, and that when you start to talk about the U part and can we actually use CO2 effectively in production, what we use it for and what does it go on to become, and does that really take carbon dioxide out of the atmosphere and for how long, is part of the ongoing challenge. But this U part is the utilization bit is fascinating and I think interesting for us. So I think and where it's relevant, I think, is what kind of CO2 matters if you're going to use it. So bio CO2 is really important if you're going to turn it into another product, because nobody wants us to be able to feed an industry which is using fossil fuel to produce CO2 and then we're making other things from it. So it should be coming from places like sugar or paper and pulp, or even our own renewable bio routes for renewable fuels from the organic sources. But in that space, you then still have to capture it and have the right amount of renewable energy in place to be able to capture it and distribute it, to bring it in to make it a feedstock. So the challenges is around renewable energy being intermittent and being able to capture bio feedstock in a place where you can do it consistently alongside alongside processes which give you access to the right kind of CO2, and then bringing it to somewhere to be able to use it effectively. And I think all of those amount to different parts of a process, different parts of a challenge, where we look at saying, we need to build the right, like I said before, relationships, partnerships to access the right product, collect it in the right way and bring it into the refinery, and use our own supply effectively.
Thanks, Julia. Alan, Taoufik, any thoughts?
Yeah, sure. Let me just expand a little bit on the CCUS, because this is a topic dear to my heart, and this is the first project I was working on was with the Saudi Aramco. When I was working for Saudi Aramco, was to make a gas plant, carbon neutral by capturing all the CO2, transporting it, and store it in a geological reservoir. So this was back in 2012, and it was a very successful pilot. The thing for CCUS is key, and I would like to emphasize on the fact, and sorry, I will bring some numbers because it's really important to get the full picture. The part for CCUS, which is the most expensive, is correspond to the capture. And the capture, you have the pre-combustion, post-combustion, and you have also the oxy-combustion, and you have also direct air capture. We're talking about 20 to 200 euros per ton of CO2 to capture. But technology is evolving, and the oil and gas industry has the resources to reduce it. We saw, for example, the example of 1 million ton project from Occidental in the US. So things are moving for direct, for direct air capture. Then we have the second part, which is, and this could be biogenic or could be fossil CO2. It doesn't change anything. The second one, which is the transport, and this is where critics, and I agree with Julia, I agree with Alan, that regulations are really key there, because transporting the CO2, considered is CO2 waste or not? So we need to clarify this point. And even when you transport, there is an issue with corrosion. Can we reuse the existing pipelines? And again, I'll go to the optimistic part is oil and gas industry has a long experience in putting pipes anywhere, under any conditions, with any type of corrosive material. So we have the experience, and we just need to adjust it to make sure that it's still economics, because we're talking about 4 to 25 euros per ton of CO2 to transport. Then comes the part of the storage, and the storage or utilization. This is the big debate. I would like to talk about utilization. Utilization is good. Because we can put, and in Repsol we have a long experience in this area, for example, for the e-methanol. But e-methanol has also cost, because you need to get the CO2, you need to get some water, you need to get some catalyzers, and we see the issues right now with all the critical materials. So we need to add that to the picture, and we need to see the full life cycle. We do this LCA, excuse me, the life cycle analysis to see the real cost of the e-methanol. And do we need really to, and in some places, we need something like, if I'm not mistaken, something like 57 kilowatt hours for 1 kilogram of something like 3 times. The methanol between the e-methanol and the methanol, something like 3 times the cost in terms of energy, and in fact, the cost of economy. So unless you can subsidize it, it could be good for small volumes. When we talk about huge volumes, I'm sorry, this is the IEA. In all the reports, they are mentioning that the geological storage is the right way to do it. And what is geological storage? It's nothing, it's like Mother Nature. Mother Nature is absorbing the CO2. We have the ocean capture. So it's just to accelerate it. And to accelerate it, we can just capture it. I said capture, transport, then go and store it in a geological reservoir and make sure that it will stay there for 100,000 or 100,000 years, or you can also mineralize it. So you have the 2 options, and there is, I would say, what Julia was mentioning, the biogenic CO2, the BECCS. For the biogenic CO2, we can also store it, and we can get credit for it. For example, in the e-fuel, we can get some few hundred euros per ton if you are storing your biogenic CO2. So this could be good as business. So that's really interesting thing. The issue is the volume, and the second issue is competition, because when we get this corn, when we get all the agriculture, do we need to feed livestock? Do we need to feed people to feed people, or do we need to use it to get the CO2? So we need also to take that into consideration and see that there is no one solution fits all. So there are always different approaches. But this is, I don't want to really put a lot of numbers, but the numbers speak for themselves. Is the CCUS with the EU is really the key. The storage, geological storage, is really important. Storage in trees, natural storage, is good as well. But to get enough trees to capture, first, if we want to plant tree, we need to wait 30 years for the tree to be able to capture CO2, we need to plant more than double of India, just to give you an idea, to capture not all the CO2. You see, so just to give you some perspective on what geological storage, it's there, it's available.
Okay. Thanks, Taoufik. Some interesting perspectives there. I think Alan would like to get your thoughts, especially around the cost aspect, and also keen to hear your thoughts around the utilization and storage, or utilization and storage side of things. Over to you, Alan.
Sure. We've done a fair amount of work on the cost structure. The challenge is it turns out to be in the low $100 to $200 a ton sort of metric if you're looking at capturing CO2 from an industrial type process. What Tarek talked about, direct air capture, that's very difficult because you've got carbon dioxide that's at a concentration of 440 ppm. So you have to process an awful lot of gas to capture the relatively small amounts of carbon dioxide. There are processes in the refinery where you've got carbon dioxide at much higher concentrations, particularly on some of the outlet from methane steam reformers, which can bring some of the cost down. That's the challenge is you still end up with high costs because it's effectively a large gas processing facility that you're needing to do. We've looked at number of projects, and some of the sort of key lessons or key learnings that we come up with is a CCS facility benefits from economies of scale, in which case it's best suited to a large industrial complex with a variety of different producers and capturing CO2 from the streams where it is the most concentrated. But actually it needs to be considered almost like a utility, because there's a fair amount of capital that needs to be put down just in terms of the amount of equipment and kit that needs to be put in place to do that capturing. So if we're looking at sort of the implications for Europe, then with the European sort of EU ETS charges at the moment, they're probably too low to make CO2 CCS economic in terms of deferring or avoiding sort of emissions charges. It's only in the sort of the mid to late 2030s do we see that, or are our forecasts that European CO2 prices will be sufficiently high to make it attractive. So there is an element that actually the economics of these facilities are quite challenging. There's the whole issue that Tarek alluded to around CO2 as a waste stream, and the transportation of wastes between EU states and nations is quite challenging, quite difficult. There are, however, lots of places within the North Sea where there's natural or relatively easy places for the CO2 to be sequestered. Lots of fields, lots of infrastructure where the CO2 can be quite readily just sort of placed into locations where it will remain for a very, very long period of time. So if we're looking at this whole aspect of which locations are better suited to those facilities, it's ones that almost are the converse. Those facilities that benefited from the proximity to North Sea oil and gas or to Gulf of Mexico oil and gas will be in a good place for, rather than extracting out, putting sort of CO2 back down into those geological formations. The longer term aspirations of utilizing that for synthetic fuels, you end up, and this is what Julia talked to, you end up with the challenge that within the European current regulations, that actually industrial emissions don't really capture much or any of the credit that will come from generating synthetic fuels. if they are from industrial processes. So they need to be biogenic. So this challenges some of the economics around some of the projects, because I think the timing for that is in the early 2040s. We are in the mid 2020s. These projects are, if they're going to be large, will be long lead times, in which case not having the ability to reuse the industrial CO2 as part of the circular economy becomes a bit of an economic challenge. So there's some things that have been put in place to really ensure that any CCUS is carbon negative through sort of biogenic sources, but that challenges sort of the broader decarbonisation of industrial emissions. So it's something that we think the regulators need to pay better attention to, or think more holistically about, as to the regulations they currently have put into place.
Makes sense. And I think, I guess if I just pick out some of the key things from I guess what all three of you have shared, I think the partnerships aspects come out quite strong. I think being able to sort of co-locate some of this CCUS capabilities, which with some of the large sort of production or producers, I think comes out clear. And I guess also the point around this being something that is suitable for large volumes, especially if it's got to be cost effective, given the amount of capital intensive, or given the capital intensive nature of what we're building here. That makes sense. I'll just change gears slightly now and probably look at
if you don't mind, Sam, if you don't, and just so you mentioned this scale, which is great. I mean, this is perfect. And coming from, I mean, before I was in Gulf of Mexico, in charge of operations for Gulf of Mexico, and we had the same challenge, but on the other hand, which is we have some small assets, but the cost of extracting oil and transporting it was too high. But the trick, and this is again why oil and gas industry really has a lot of solutions, is that there is also a way for these small installations to be plugged to big pipe, to huge pipe. And we saw that, and this could be partial solution, but I'm 100% sure, I mean, I agree with you that the CapEx is too high for a single source, for a small plant to build the whole infrastructure. But if you can plug to existing pipe, then probably that could be possible.
Absolutely. That's a great point. I think, again, I think you mentioned it at the beginning about bringing the experience that we have already within oil and gas into bear in these sectors into bear in these domains is probably what we should look at. And yeah, we've got loads of experience where, stranded assets or stranded fields have been produced because we managed to connect into a bigger production facility or into a pipe. So that makes sense. Thanks for that, Taoufik. So yeah, changing gears a little bit, another sort of part of the puzzle, another answer, if you may, is around hydrogen. So I'd like to get perspectives from each of you around where do you see hydrogen, blue and green or blue or green fitting into this puzzle that we're trying to solve, into this question that we're trying to answer. So again, I'll open it up. Please feel free to go straight in and give me your thoughts on that, or give us your thoughts on that.
If you don't mind, I can just some element related to hydrogen, which is it's nice, it's good for the environment. But what we need to see is this is a small molecule, and 1 kilogram of hydrogen, if you want to put it in container at atmospheric pressure, it's around 11,000 liters. So imagine 1 kilogram. For your car, if we have a normal car, average car, it's 100 kilometers. So you cannot have a car with going 100 kilometers and just having 11,000. If you want to go to the size of a car tank, let's say 24 liters, we need to go down to 700 bars. That's a lot. And really or if the other way, if you want to really make it really very, very compressed, you need to go to minus 253 degrees C. So those are numbers we need to keep in mind just before we start talking about putting hydrogen everywhere. The green hydrogen, and again, I'm just throwing some numbers, is it will take more energy, more kilowatt hours to produce through catalyzers to produce hydrogen, green hydrogen, than what it will give you as kilowatt hours. I think it's twice, if I'm not mistaken, or more than twice, if I'm not mistaken. So the economy there is real, and the reason is because the cost of the electrolyzers is really, really high. So the green hydrogen is good. And you have also, we go back again to competition when it comes to sweet water, you need to have pure water. So if you need a desalination system, you need energy for it. So the lives, again, we'll go always back to the LCA, the life cycle analysis of the product. The product here is 1 kilogram of hydrogen. Is it the green hydrogen? For the moment, does not make it, unfortunately. So you need to have a lot of subsidies. When it comes to the other one, which is the famous one, which is the blue, and the blue is you take, for example, methane, and you use the reforming, and from the methane plus the CO2, so you can get something which is the hydrogen, pure hydrogen plus CO2. So you can separate the molecule, and you get hydrogen, and you get pure carbon. So this could be one solution, around about $3 to $4 the kilogram. That's something really could be interesting, and could be very, very interesting also for the industry, for the downstream energy, for refineries, and for all the plants. So that could be one solution really and it's purely, it's for recycling. So it's for circular economy. So hydrogen, blue, especially the blue one, for the moment could be one good solution. But again, it has a cost, and the gas, do we need to use the gas, and especially the methane? Do we need to use it for generating hydrogen, or for your plants? And the other thing is the point that we never mentioned is that methane has. There are these emissions of methane, because when we see greenhouse gases, it's not only CO2, it's methane. Methane is has more damage, causes more damage to the atmosphere than CO2. Even if the life cycle of hydrogen of CO2 is 10 times the one of methane. So that means methane will dissolve in the atmosphere faster. So we need to take that also into consideration. There is a good point is, if there is enough gas, like in the US, which is the biggest producer for the moment with Canada, then you can generate a lot of blue hydrogen, and you need to add to it, of course, storage. And we go back again to the CCS. You need to get this CO2, separate the CO2 from the process, from the gas before, and store it, geological storage, use geological storage to do it, to get really the real blue hydrogen.
Interesting points there. So looks like it's a trickier solution than not as straightforward. So thanks for that, Taoufik. Alan, Julia, thoughts on that? Not as straightforward as we would think it is. Keen to hear your thoughts.
Julia, away you
go. Yes, of course, it's not going to be as straightforward. I think if you're going in the direction of saying, okay, we want to make an e-product, our focus needs to be on green hydrogen, which, recognizing it, comes with the challenges of plentiful renewable energy in the right supply, access to the right kind of water, to be able to do it, and thus forming the right kind of partnerships where you do have access to that water and energy supply. Fortunately, we do some in Lower Austria, where we're not taking water away from an energy or from agriculture or growing, and actually managing it effectively, and are able to put water back in to the environment afterwards. But if you want to use the hydrogen in your refinery, blue hydrogen will work, and we do, but we also want to use it to make these products. And blue hydrogen still requires steam, it still requires water to make it. So there are some elements of, unpicking different parts of which ones are viable. They've all got a place, and there is a longer term investment for sure, and some trust that the infrastructure to support green hydrogen will be built in time, and that you need to lobby and create the right relationships and partnerships to be able to do it. But there's also for us a part about transporting hydrogen, and we can perhaps make the most of the fact that you can transport it as methanol, and in methanol we can use that to make olefins and to make eSAF. So if you accept it as a feedstock, hydrogen and carbon dioxide have a place, because there may not be enough alternative renewable feedstocks from the bio sources, that actually there will still be demand for the hydrocarbon based products beyond what we can make from renewable feedstocks. And if you take that as a premise, being able to turn it into something with hydrogen, with bio CO2, means that building an infrastructure around it will be needed, and the longer term investments and risks around those investments are there, but we need to concentrate on building the right type of protections, legislation and collaborations that help us change and improve that set of circumstances for us.
Fascinating. It comes back to flexibility and partnerships. Alan, please.
Saying it.
Yeah, absolutely.
Okay. Like I said, there's not much really for me to add, because of what Tarek and Julie have already covered. Challenges that we see around low carbon hydrogen is the ability to deliver it at scale and its cost. So our sort of analysis suggests that sort of either method doesn't really become competitive against grey hydrogen, so methane steam reforming, until the mid 2030s, and a big part of sort of that analysis is factored upon the how the cost of carbon dioxide emissions are factored in to that broad analysis. So going back to sort of Tarek's earlier point, there is no silver bullet for this energy transition and circular economy. We need to look at lots of different options. We need technology to improve. We have a refining industry that does a fantastic job of doing very complex, hazardous chemical conversions in a very safe manner. The need for liquids will remain. They need to become lower, sort of, not to decarbonize. They need to become more circular, and the sort of refining and petrochemical industry knows how to do those chemical transformations. The challenge comes around the economics, because we have an industry that's built up over decades and is very good at what it does and is very efficient. These new technologies are much smaller scale, they're nascent. It's a different industry mindset, which pulls to Julia's point around partnerships. But the key aspect is the regulatory support that means these private sector companies are willing to make a commercial decision to invest on the next one, the bigger one, and then we generate the learnings from that and help the whole industry start this broad transformation away from fossil based to becoming much more circular.
Fascinating. Thanks for that, Alan. I think I can probably continue this conversation for another few hours. I think there's just things in here that we can go into separate conversations about. So first of all, I guess amazing. Thanks for this. Thanks for the perspectives all of you shared. Conscious of time, what I'll probably ask is a quick round of closing thoughts from each of you. And I think also I'd like to touch upon one of the questions that come through. We've discussed things that can really help, or themes that have been sort of repeating throughout. There's regulation that needs to support. There's partnerships that need to be looked at. There's flexibility aspects, and there's sort of long-term investment aspects that have all come through quite strongly in all of the sort of discussion we've had till now. One aspect is around technology and AI, and I mean, you're having a conversation with a Microsoft person. AI is going to enter the conversation at some point, right? As we go around with your closing thoughts, I'd just like each of you to just quickly touch upon the potential. Do you see that as an opportunity for both the CCUS side of things, but also the hydrogen side of things? So yeah, we'll start, Julia, probably with you this time around. Your sort of thoughts and wrapping views, if you may.
Yes, then the answer is yes, there's an opportunity with AI, both in the traditional sense, because, hey, if you're using any kind of machine learning to predict and do your analytics and maximize your facilities by learning from the data and predict where the challenges are, that's going to be helpful also to track and use energy when it's at its best price, predict where the right places to put things are. All of those aspects are really helpful in terms of AI and what we do. But I also think there's huge opportunity in terms of what you do with the molecule. If we're looking at this and bringing it back to a circular economy, where alongside AI, I think blockchain plays a role, albeit both of those have an environmental impact and a considerable one right now. But the opportunity to innovate in this sector is not just around how do you make new products from renewable sources, it's how do you continue to make sure that they're part of a supply chain. Because if you turn it into a polymer, it's no longer a recyclable liquid, it's a cable or packaging or hardware or clothes, and how you design to make those effective in the future. Potentially there's a role for AI to play there, and how you make sure it's a useful feedstock, how you trace that molecule is where there's loads of opportunity for digital technology. So I think bringing back to, hey, this is a discussion about the circular economy and how you use carbon and hydrogen as a feedstock for that. You then continue to make sure it's traceable throughout its hopefully many lives, not just in the reuse aspect, but also in the recycling aspect. That's me.
Thanks, Julia. Alan?
I'm trying to think how I can add to Julia's comments, actually. That's sort of very tricky. What we have is an industry, if you think of a refining and chemical industry that is getting older, there needs to be a huge amount of knowledge transfer. I think AI can help us do that. It can also support how we adapt this sector to become more circular, addressing many of the points that Julia talked about. We need the challenge one of how do we accelerate the learning curves that have been traditionally related to how much costs have come down as volumes have broadly doubled. We need to accelerate that if we're going to accelerate our broad decarbonisation, which is what we need to do, because our base case outlook across all the commodities is we end up with a world that's quite far away from net zero, so something more like 2.5 degrees C rather than 1.5 by 2050, reflecting our broader outlooks on sort of the energy transition and our view as to what is a realistic pathway. So we as a society need to get better at becoming more circular and decarbonising what we do. AI has got to be able to help us with that. The challenge with it is the power load, because if I think about gas team, one of the things that they're very focused on is the additional electrical power that is required for these AI data centres, and it could well mean that natural gas demand for power in the US may do something it's not done for a very long time, which is actually grow, because it's tended to be flat or declining. So again, going back to Tarek's earlier point, there is no silver bullet, so we just need to make the best use of what we've got.
Thanks, Alan. And Taoufik, over to you.
Yes, so I'll just add, those were really very, I mean, to the point, the thoughts were really to the point. And the way I see it is to add on top of this is for AI. AI is critical. I mean, for me, we we need to put it everywhere. We have from Repsol technology lab, our technology lab, 240 researchers, for example. We have a department for optimization and the goal, and also for advanced mathematics. So what we do is we develop models, sometimes even to see the different molecules, how to optimize the process, and to make sure this process, for example, will reduce the emissions, or how, for example, the polyolefin, to make them some carbon neutral, how can we do that? And we can run simulations, and with the computation power, we can have multiple realization before going to the lab and try some pilots. So AI is definitely very, very important and key. It's also important for to put some kind of business development plan. It's not only technology is really important, and also for the economic part, to do multiple simulations and to see what could be the process that will bring some value to the circular economy, but also to be from economical point of view, to be sound. So machine learning, I mean, you just name it. I mean, all the aspects of AI, large language model, all those are really mandatory for the downstream and for the circular economy in general, and for the oil and gas in general.
Yeah. Cool. Thanks so much, Julia, Alan, Taoufik. Thanks so much for that. Like I said, I could continue this conversation for hours and hours, but we'll call it a close here. Thanks to everyone who's attended. Thanks for your questions. Hope this has been an insightful session. And please do reach out to any of us in case you've got any further questions. And with that, I'll probably hand it back to Adam.
Thanks so much, Sam. That was brilliant. As Sam mentioned, if you want to connect with any of the speakers, please do that. I think they're on the app, and also contact them directly for any information. I love that, because it was interesting what Taoufik mentioned. I don't know if it's Taoufik or Julia, about how you should, it's knowledge transfer, isn't it? So I think going into this realm of energy transition, it's transitioning this knowledge that we have in oil and gas about dealing with deserted assets, and actually using that knowledge in the energy transition, carbon capture, hydrogen, wind power. Very, very interesting topic, I have to admit. Flexibility and partnerships. I think that's what it came down to. That was what I learned from the session. If I was to do 3 words, I was going to say 2, but 3 words: flexibility and partnerships. That was a really, really important takeaway I had for the event as well. And as probably Julia mentioned, I think, and Alan, there's no silver bullet. There's a lot of multiple minor bullets, or bronze bullets, as sort of as has been said before, but not silver bullets. And it's interesting how we concluded that conversation. Really good that you did that, Sam, actually, about the technology, and obviously talking about how AI potentially could be an enabler for transitioning to a lower carbon future. So that's really good to have everyone's key points on that as well. Fantastic session. Thank you so much for contributing, Julia, Alan, and Taoufik, and also Sam for moderating.